Good morning, geometry. I hope you're having a great day. So here's our lesson for today. As you can see, you should be able to see my screen, which says GU8. So we're geometry unit 8. Today is day 20 of semester 2. It is March 2nd. We will be working in unit 8 on circles, arcs, sectors, so some circle stuff. We'll also be working with quadrilaterals, and we're also going to be working on regular polygons. So through all of this, today I intend to just review area and perimeter formulas. There are really no perimeter formulas except for circles, but review the area formulas for a number of shapes. The assignment that goes along with this is Delta Math. It is GU8. I believe I titled it, give me a second, Apple Pen did not connect. I believe I titled it area and perimeter. There we go. And it's a little bit of a fun assignment, fun via PK, but just some problems for you guys to work on that will allow you to practice circles, area, perimeter, quadrilaterals, and regular polygons we'll get into. I will tell you this, I anticipate that this test will run after spring break, probably not until the beginning of April. So it won't be like right after spring break. It'll be kind of like a couple of weeks after spring break, but we'll be going through there. So just to recall, circles, we worked on the equations of them last time. We are going to just reiterate that again, this distance from the center of the circle to the edge of the circle is R, that is your radius. And in order to find the circumference of a circle, anybody remember what the equation is? Awesome. Circumference is equal to 2 times pi times r. Sometimes we will abbreviate pi or approximate pi as 3.14. Sometimes we're going to leave pi in the problem. The problems that I did say to use pi, they say don't give me a decimal approximation. So you're going to do the work with that. The other formula, there's one other formula for circumference. And it actually has to deal with when we don't know the radius, but we actually know d being the diameter of the entire circle. And the circumference in that case is just pi times the diameter, which should make some sense because we know 2 of the radii together is equal to the diameter. So again, just recalling these formulas, area of a circle is equal to pi times r squared. So none of this should be new, just some practice stuff. So just recalling these formulas. These are the notes that you're probably going to want to make sure you have and you upload to Schoology. Squares, what makes a square unique? You are correct. All 4 angles in a square are right angles. All 4 sides of the squares are congruent. Okay, so perimeter is just 2, let's call this side S. Yes, let's call that S. The perimeter formula is S plus S plus S plus S, because there's 4 sides, add up all the sides, perimeter, or 4 times S. This is the only other formula for perimeter that I'll probably write. I'll leave you guys to get most of them. Area again, a square is a rectangle, so our area is side times side, or side squared. Don't know where that was doing, but it's all good. All right, rectangles. Rectangles are just like squares. All 4 angles are right angles, but opposite sides are congruent and are parallel to each other. Okay. If this is length and this is, let's actually make this one length. And this is width. Perimeter is equal to 2 of the length plus 2 of the width. And area is equal to the length times width. Some of you may have seen base times height, same difference. Okay. And remember, you guys can always pause the video if you're taking notes and I'm going too fast. Parallelograms. What makes a parallelogram unique is that the opposite sides are parallel to each other and they're congruent to each other. Okay. Perimeter, if this is a length and this is the width, the perimeter is still 2L plus 2W. The area is a little different. In order to find the area of a parallelogram, we need this distance to be given to us, or we need to be able to find this distance. We actually be able to need to find that distance, and we're just going to call it, it makes a right angle with the base. We will call this the height. Okay. So that means the area of this is in this formula, because we have W as our width, it'll be width times height. Okay, so that is a little bit different. Imagine if I chopped off this corner, I could put that corner over here, and then what's my shape? So if I chopped off the left corner and I moved it and I made it a red corner, this whole shape would be a what? That whole shape would be a rectangle, hence W times H. Okay. So I'm going to erase this so it doesn't confuse you guys. But you can see that W is the entire base of the bottom, and then the height is the actual height of the parallelogram. Because again, remember when you go to the doctor and they ask you to stand up so that they can measure your height, they do not have you stand slanted, do they? They have you stand right up and down, straight up and down. So again, height has to make a right angle. Therefore, the height has to touch the ground at 90 degrees. Okay. Let's pick another color. All right. Next shape, trapezoids. How many of you have seen a trapezoid? Good. Trapezoids. Opposite sides are parallel to each other. They are not necessarily equal to each other. Okay. Opposite sides are also not necessarily equal to each other. So what we do need in a parallelogram, or not a parallelogram, a trapezoid, is we have to have the height in order to find information about the area. Perimeter, again, perimeter, I don't have a formula, but you get the perimeter by adding up all the sides. The area formula, we'll call this base 1 and this base 2 because they're different, and we have the height. So the area formula is base 1 plus base 2 times the height. Well, that kind of makes some sense. It's kind of like length times width. But because base 1 and base 2 are both of the heights, we actually need to take half of this. So basically what we're doing is we're averaging the two bases together to get the base of a rectangle, and then we're multiplying it by the height. Because if we think about a parallelogram, that width, it's the same on the top or the bottom, right? So it's the same on the top or the bottom, so it's just length time or width times height. In a trapezoid, the top and the bottom are not necessarily the same size. So we actually need to do some mathematics on it. So we actually find half of base 1 plus base 2. So we take the average and then we multiply it by the height. And that's going to be our area formula for a trapezoid. Okay. To recall, per triangles, again, we got to have that height. Height makes a right. We also know this is our base. So area for a triangle is 1/2 base times height. And again, perimeter is add up all the sides. And therein lies my notes for today and the stuff that I'm gonna ask you to practice. The stuff that I'm gonna ask you to practice requires to use your little brain cells a little bit. You may want to get a piece of paper out. You may want to draw some things. I have absolutely no problem if you guys are working together. I think more brains together is helpful. These are not problems that you're going to be able to put into photo math. You're going to actually have to think about them. I love you, but that's good for you guys. Hope you guys are having an awesome day. Take your notes, upload them to Schoology, and then work on the Delta Math. That's what I'm asking you to do for the rest of today. Thank you, and I will see you on Friday.